Okay, let me do another one. So the next problem is find the area between the graphs of y equals x squared minus 5x minus 7 and y equals x minus 12 over the interval from minus 1 to 5. And again, the first step would be to visualize what is it exactly that the question is asking for. And the best way would be to sketch the graph. And I will use Wolfram Alpha to sketch the graph. So I will ask to plot x squared minus 5x minus 7 and x minus 12 on the region, on the interval from minus 1 to 5. And then Wolfram Alpha understood me perfectly. It understood I wanted this plot, and it gave me two pictures. And it will be your job to understand which one is the useful one. What do you think this parametric plot is about? How can you interpret what I asked for parametrically? You can interpret, yes, you can interpret that as x equals, well, your x coordinate, here's your x coordinate, changes according to the first function, your y coordinate changes according to the second function. And this pair of equations represents a parametric curve where parameter x changes between minus 1 and 5. So that parametric plot is about totally different object. And what we need is exactly this plot of two graphs. And what we see is that there is a region that the graphs bound, but we have specifically mentioned the interval from minus 1 to 5. So that means we have to limit our attention to this interval, and whatever those two curves bound over that interval is what the question is asking. So we have to look at this area plus that area. And we have to think about both areas being positive, because that's exactly how question is worded. It's worded geometrically. It's asking for positive area, so we need to add this area and that area. So let me try now to set up the integral. So my idea would be to cut those areas vertically. Again, as I did before, cut vertically into shapes, and those shapes, being narrow, will resemble rectangles. So I will explain my model case again as the case of rectangle, when the area of a rectangle is equal to the width times height. And then I will try to reduce the general case to this one by cutting the area into pieces. So I will choose my parameter to be x, and it will change from -1 to 5. And then what? I will subdivide that interval -1 to 5 into short subintervals of length delta x. And then again, the region is subdivided into pieces subregions, and those subregions are approximately rectangles. And this is exactly my link to that model case. So if I introduce my notation now, if the ith region has area AI, then on one hand, the total area is equal to the sum over I of all those areas. But then each AI is approximately the height of that ith region multiplied by the width. And the width is delta x. And then again I claim that I expect those approximations to be better as delta x goes to 0, and I expect my area to be limit as delta x goes to 0 of those sums. And then as soon as I realize that the ith height is a function of not delta x but xi, then this will become an integral. So I'm thinking now about the height as the height at some point xi, and let's look at the graphs. Well, the thing is that if I think about some point xi here and about that rectangle, the height is computed as the difference of values of the two functions. But it is the difference of blue minus red on this side and the difference of red minus blue on the other side. So I have two different cases to cover. My height will be computed differently depending on where xi belongs. And I see from the picture that there are exactly two cases. First case is that I compute difference one way, and let me introduce now the notations. Let me call this f of x and that g of x. And then the height is going to be f of x minus g of x if what? If xi is between -1 and 1. Right? And then it will be g of xi minus f of xi if xi is between 1 and 5. So what I'm getting here is I'm getting the partially defined function of xi. It's defined by different formulas on different intervals. But the formula will give me the integral anyway. My total area is going to be an integral from -1 to 5 of this function height of x integrated with respect to dx, with respect to x. And the rest is just computation of the integral of partially defined function. And in the computation, you split the interval of integration into two subintervals. This integral is the sum from -1 to 1 and from 1 to 5. And then you can substitute the values of the height function depending on which interval you use. It will be f minus g here and g minus f there. And the rest is computation because, again, the formulas for f and g are given. So I will not finish computation. And of course, Wolfram Alpha can compute that thing for you. If you ask properly. So it understands the input area between, it interprets it as area between the graphs, it writes down the integrals immediately, computes the positive area for you, and you see that it splitted the integrals into two different ones. Well, of course, it doesn't explain why it does so. It just tells you what it does. And what I will expect from you is explanation of why. So don't bother doing computations by hand. You'll have to explain. All right, any questions about this problem?